Hello, I'm Calf, and I'm here to give you this one weird trick that's going to make your modern SSD run faster in Windows 11. Because Microsoft finally decided to give the OS the ability to talk natively with these modern drives instead of having to use a translation layer like they have since forever. Of course, the catch is they only officially enabled it on Windows Server for all the fancy AI workloads or whatever. But you can see these instructions on screen. All you have to do is, as seen on screen, you just gotta take one of these at a time, copy them, and you go to an admin terminal. I have one prepared here. And if you don't know how to go to an admin terminal, all you have to do is right-click your start button here and go to Terminal Admin. This is where the pink one goes to. Oops, that yellow one's for later. Now, if you pull up our terminal, we could just, since I'm using PowerShell, you can either have to type it in manually or with PowerShell, I just right click and you just run the function like so and like that. And you just do that with the other two instructions as well. And you just have to, once you do them all, you just restart your computer. And then you pull up Device Manager, which you can pull up from here. I have one prepared for you. As you can see here, since I ran Device Manager, I have two storage disks here. This is where all the ones that, if it recognizes it and uses the new driver, it'll go here. As you can see, I have two drivers here. And to show the speed differences, I have these benchmarks. These are basic Crystal Disk benchmarks. This is for an Optane 905P. Very high-end, very niche drive. But it's one that is very CPU limited. And yes, I do have to feel like that's the other thing I need to note about it, is that CPU limitations is, in fact, how most of these gains are from. As the native drivers means it uses less CPU workload. And I'll have a good example of that shown in just a second. So, this is just the base numbers, and here are the numbers after I run those drives. As you can note, there are some big gains here. And this is just from running a few command line prompts. Big gains. And now I have another drive here. This is a PCIe 5.0 drive. Big boy, big speeds, big fast, but not so big on the random 4K numbers. Ka-chow! Just like that. We get some gains here, especially on the queued up 4Ks, and even on without the queued. These are still good numbers, and these would be great for all your older video games that don't use direct storage or other ways to get around this whole problem in the first place, like compiling code, all stuff that this gets big time benefits. And even there, we still get benefits in our sequentials for trying to load a whole bunch of stuff at once. And I have one more benchmark. This is from a computer, a Sandy Bridge Xeon. Think of it as like two Intel i7 2600s glued together at once. And these are the numbers from this. This is from a Kioxia White Label PCIe 3.0 drive. This is like average, ordinary OEM drive. Now, the writes are higher than that. That's because this drive has pretty much a RAM cache that it puts to and says, hey, everything's all good and dandy. And yeah, this is on a pretty old CPU, one that's not even officially supported by Windows 11, but I got around that. Now, and with this though, you do lose a bit of our sequential reads and some of the random writes. This, I think, is just because the drive's firmware was optimized for this kind of way of work. But you also know at the same time, we get some pretty big random reads and all that. This will still probably help give a bit of extra performance, even if the drive really doesn't have much else to offer or give. And I will put in the comments everything you need to type down that I put on this notepad here. I'll put this in the comment. I'll put it in that top comment and in the description, so you can just copy that in and have some fun. And yeah, have fun.